So this is a quick demonstration of ordinary least squares regression using the ESS dataset. And I'm going to show you a couple of different versions of this command just to explain what each of the different prefixes does, and also to explain the ordering of the variables and why it's important to acknowledge the level of measurement of the variable. Now, to run an OLS regression in Stata, the basic command is either regress or reg. It'll recognize either version of these as regress. And the dependent variable is quite important when you're running regressions in Stata. The ordering of the variables is important. So your dependent variable must come first in the command line after the base command, and then your independent variables come after. So it's regress or reg, dependent variable, and then your set of independent variables afterward. If you need to revise some of the theory behind interpreting this and what's going on in the specification of a regression model, please return to the course slides for the relevant weeks to revise them. I'm just going to talk about the conduct and interpretation here. So let's look at this example where we're conducting a regression where our dependent variable is immigration and one of our explanatory variables is age. We can run that or produce that model by running the command as follows, and we get a table of output. Now the key pieces of information here are, of course, our overall model significance, our f value and the associated p value. And again, this is testing the hypothesis that the population value of the coefficients is equal to 0, and we see that it's quite unlikely that this is the case. So this is a statistically significant model. Our adjusted R squared shows 0.0112, and remember that this can be read as a proportion or a percentage. So we're explaining about 0.01 or about 1% of variation in attitudes towards immigration using age. Next thing we want to know is what is the effect size. And we see that for each additional year of age, there is a corresponding reduction in average sentiment towards immigrants of 0.013. And so we will report this to 2 decimal places, probably, so 0.01. So each additional year of age results in a decrease in favorable attitudes towards immigrants. So again, age is, or we could also look at the sign first of all and say that age is negatively associated with our dependent variable. We also get a figure for t, and we get a value for p of 0.000. So p in this case is less than 0.05. So this is a statistically significant effect. So this is an example with one variable. What if we want to add more? And we see here we've got these 2 additional variables. We've got marital status and we've got household income in bands. Now there's always a risk when you produce a model like this, that when you're using categorical variables, if you just run the command with the variable name as it is, you'll get something that looks like this. And this is problematic. Why is it problematic? Because if we examine the tables of these individual variables separately, we see that these are actually categorical variables. So in a sense, if we just were to run the model like this, Stata is automatically treating these as numeric variables, even though in fact they aren't. We have to tell Stata that these are categorical variables. So what we want to know is the effect of being in a civil union, the effect of being separated, the effect of membership of each of these different categories on average attitudes towards immigrants. Similarly for this one, households total income, because it's measured in this sort of ranked decile format here, we want to know what the effect of being in the second, the third, and the fourth, and so on, relative to the first is. So to do that, the proper specification for this command is to include the I dot prefix. I dot marital, I dot age inc. And again, if we were to include age in this, we would leave age as it is because age is already a scale variable. We don't need to worry about modifying that. So we leave the scale variables as they are. The categorical variables, that's nominal ordinal variables generally speaking, they go in with the I dot prefix. When we do that, we get a, variable name, aj. When we do that, we get a slightly longer table of effects. Now we get a partial effect for age. We also get each of the individual effects for each category of marital status and individual effects for each category of household income. We can see here some changes to our model. Now the diagnostics are showing us that the adjusted R squared is 0.045. So we're explaining about 4% of the variation. Again, not a huge improvement, but something of an improvement. Age is still statistically significant. P is less than 0.05. And the effect looks more or less similar to what we found up here in the original model with just age, negative 0.01. In terms of marital status then, When we enter a categorical variable with the I dot prefix, Stata is going to give us the effect of being in this group relative to the base group. Unless you tell it otherwise, the reference group, the reference category, will always be the first one. So in this case, it's legally married. So this is category 1 in the marital variable. So this is the effect of being in a legally registered civil union relative to being married, separated relative to married, widowed relative to married. So for each of these, we can see that for those who are divorced, their attitudes are on average 0.20 above or greater than those who are married. For this group here, widowed civil partners, their attitudes are 0.15 points below those who are married. So it's relative to those who are married. Similarly, for the household income, we are now comparing, because the reference category is automatically the first, we are comparing the attitude, the effect size for each of these categories against the first group, the reference group, so against the lowest income group. So relative to the lowest income group, we see that those in the second decile have a difference of 0.25. So the attitudes are, we round it to 2 decimal places again, 0.26 above or greater than those in the first. You can kind of see this linear effect happening here as we go up through the household income ranks to the very top one. Favorability towards immigrants increases so that by the time we get to the 10th decile, there is a difference in average sentiment towards immigrants of 1.4 for those in the 10th decile relative to those in the first. So that's how and again, we want to check for each of these different groups here. There's none of them statistically significant for the marital status one. And there are a few. So the top income groups here are significant. The others, particularly the second, the third, and the fourth decile are not. So we have significant effects for the upper groups, for the higher groups. So that is a short tutorial on how to conduct linear regression with scale and categorical independent variables in Stata.